Hi everyone, this is Mr. Chang. Here we are in lesson 5. We're going to learn about rational exponents. Lesson 3 is on integral exponent, which means you can have negative number in the exponent. Now, rational means you can have fractions in your exponent, a to the power of 1 over n. What does that mean? All right, so make sure you understand the negative exponent and then don't confuse with that one. This is another rule. So it will take some time to understand it. The nice thing is this is the last rule. Okay, there's no more because we cover everything with the exponent. Let's investigate what does it mean. Now, if I have root 5 times root 5, it means, what does it mean? Root 5 times root 5, we can say root 5 times 5, right? That's root 25. It just become a 5, right? So root 5 times root 5 is a 5. Now, how about root half times root 5 to the power of half times 5 to the power of half? So you have powers, multiplying them together, you add the exponent. So 5 to the power of half plus half. Well, what's half plus half? That's 1. 5 to the power of 1. Well, that's equal to 5. Okay, now we have something very interesting here. Root 5 times root 5 is 5, but root 5 half times 5 half is also 5, which means they give the same answer. So they must equal to each other. Like this one must equal to each other. That's why they have the same result. So root 5 is equal to 5 half. That's the interesting result. Now let's try another one. Cube root of 2, cube root of 2, cube root of 2. You multiply 3 of them together. They have to have the same index in order to mix them. So become cube root of, you multiply all the 2 together, is 2 to the power of 3. So this cancel out, you're having a 2. Same argument here. How about 2 to the power of third times that, or 3 times together? You multiply powers, you add the exponent. When you add 1/3 together 3 times is 3 over 3. The same as 1. So which just give you a 2. Same result. Okay, this must be equal to that. So we saw that cube root of 2 is equal to 2 to the power of 1/3. So do you see do you see the patterns here? So when you have 5 to the power of 1/2, this 2 is same as having a square root here. If you have a 2 to the power of 1/3, this 3 having same as having a cube root here. So the denominator in the exponent mean the root. So that's our rule. So let's apply this rule here. So C, so what do you do? This is same as square root. All right. So this means square root of 25, which just give you a 5. Like where does this square root come from? Come from the denominator. Okay. What do we do with the 1? So far everything is 1. So we'll, in next investigation, you'll see what happened to that number. This means raised to the power of 1, which means doesn't change it. Here, denominator 3 means cube root of 64, which is a 4. Fourth root of 81, which is a 3. All right. Here, write them in radical form, square root of x. When there's a 2, you don't need to write it. Cube root of b, 10th root of p, nth root of a. So that's the meaning. This is like the rule. That's the meaning of having a power of 1 over n. Next part. How about, more generally, to the power of m over n? Okay, so let's do the investigation. Here, m over n. This is what we try to deal with. Let's look at an example first. Square root 5353 is square root. You can combine them. That's become 56, right? Remember, as long as the index is the same, then you can multiply them, combine them. When you multiply powers, you add them. So this is, you can write that based on the previous rule. You can write that as, if you square root that, right? become a 3. Why? Because 5 3 times 5 3 is 5 6. So when you square root that, that's give you 5 3. Here, when you multiply this together, it's same as having that 3 over 2 plus 3 over 2. When you add fraction, the denominator stay the same, it's a 2. You add the top, it's a 6. So that's 3. Same answer. So therefore, this thing must equal to that. So root 5 3, same as 5 3 over 2. All right, so the numerator is your power, the denominator is your root. So the other investigation will show you the same thing. All right, so I'll just jump to the answer here to show you, jump to part C. X, numerator is your power, denominator is your root. Numerator is your power, denominator is your root. Numerator is your power, denominator is your root. Well, for a 2, you don't need to write a 2. You just leave it like that. So generally, the m stay there, the n is your root. So this is more general. Like it works with the 1, right? Then this is just a 1, which is the same. So the m over n is the more general form. Okay, so they have just another, now showing you numbers. I'll write the examples here. Right, what does this mean? This is your power, this, and then you take square root. Now, you can also write, they have another meaning here. They want to show you, if you cube a number square, it's same as square the number cube. The order doesn't matter between square, between power, and the root. They have the same rank, same order. So it doesn't matter. So when you have this, instead of cube it first before you take square root, because cube become a huge number, you can square root it first and then cube. Well, square root that we know is 8, which give you 5, 1, 2, which is easier. Okay, same here, right? So this is the meaning, but you can also swap this around and put the 5 on the outside. So square root of 4 is easy to deal with, it's a 2. 2, 5, 32. Same here, right? You can cube it and then fourth root, or you can fourth root it and then cube. It's the same. So this is what the second investigation want to show you. So fourth root of 81 is a 3. Cube 3 is a 27. Finally, what if we combine with negative? Wow. Okay, what if we combine with negative? Okay, so negative and then a fraction. So, well, let's use our exponent law. With the negative, right? With the negative, we know it means flip this whole thing to the bottom and then change the exponent to positive. And then next, that means this. All right? So we summarize what we learned today here. If you have a to the power of m over n, is a nth root and then m. All right? Or you can m first and then nth. Usually that's better because if you take the nth root, it make it smaller and then you put it to any exponent. But these two are the same. All right? And if you have a negative exponent, then reciprocal. Put it in the bottom. Okay? One mistake people make is they will take the reciprocal of m and become nm. So that's never the case. Don't do that. All right. Negative mean you take the exponent of reciprocal of the base. So a is on top, now become bottom. And then you still multiply m over n. M is the power, n is the nth root. You can either put the m on the outside or put the m in the inside. It's the same. So that's rational exponent. That's the main objective of this lesson. Let's look at some example. All right. So I will take the square root of 25 and then cube it. So that's 5 cubed, 125. All right. Now how about this one? Negative exponent. Negative means you flip this to the bottom first. So see, this is easy to understand. Now, 3 means you take the cube root of that and then you square it. Cube root of 27 is 3. 3 squared is a 9. All right, so let's do it one more time. Same thing. 1 over, all right, fourth root of 16, and then cube it. Fourth root of 16 is 2. 2 cube is 8. All right, how about G? All right, G. Well, you need to deal with the bracket first. 9 plus 16, and then square root of that, because remember half means square root. Square root of 25, that's a 5. Okay, without a calculator. That's why I'm not using a calculator. Okay, so more example here. Let's move down, more example. And number 2, I like this because they show you the exact same thing, but then one is positive, one is negative. Here, you can take the square root of this mean, right? Both of them. And then you can take a square root of both of them and then cube it. Square root of both of them and then cube it. Right? You don't need to write a 2 there because the square root mean 2. And then this denominator is the square root. Now finally, 9 square root is 3. 3 is 27. 4 square root is a 2. 2 3 is a 8. How about we have a negative exponent? Then you flip everything like that. And then the rest will be the same, right? You can apply this to both numbers. So square root and then cube, square root and then cube. So you have the same number but flip. Example number 3. All right, cube root of r, working with variable is actually easier. S 4, 7, right? Oh, negative. So flip it to the bottom first. And then 6 root. So the negative exponent doesn't mean the term is negative, it's positive. Okay, it just means flip it to the bottom. The fraction means the root. Finally, flip it to the bottom. And then v square root cube. Or you can put the cube on the outside, doesn't matter. Alright, so that's pretty much. One more example, example number 4. Here, this means you take the cube root of 64 and then you square. Alright, cube root of 64 is 4, 4 squared 16. Now this one means you take the cube root of negative 64 and then square. Well, can you take cube root of negative 64? Yes, you could. Become negative 4. Negative 4 squared is still 16, positive. Alright, so that's interesting for both of them because you have a square here. So it doesn't matter positive or negative, they finally become positive. 16 here, you can take square root of that and then cube. Sure, square root of that is 8. 8 cubed is 5, 112. So 3 of them have an answer, but the last one has no meaning because you try to take a square root of a negative number and then you cube it, right? Or even if you cube it first, it's still negative and then you square root, you still can't do that. No solution. So the last one can't be done. Alright, so that's it for this lesson. And you can try the homework and then we will work on the homework together. So thanks for watching. Bye.